Have you ever wondered how computers and smartphones make decisions? It all comes down to combinational logic circuits. These circuits are the building blocks of digital electronics. They process information based on a combination of inputs. Think of it like a light switch. The input is you flipping the switch. The output is the light turning on or off. Combinational logic circuits are predictable and reliable. They are made up of logic gates that perform basic operations like AND, OR, and NOT. By combining these gates, we can create circuits for complex tasks. Combinational logic circuits are everywhere in our digital world, from your smartphone to your car. Designing a combinational logic circuit is like solving a puzzle. First, you need to define the problem you want to solve. Let's say you're designing a circuit to control a sprinkler system. You'd need to decide what inputs the circuit should have, like a rain sensor and a timer. Next, you would create a truth table. This table lists all possible input combinations and the desired output for each combination. For example, if it's raining and the timer is off, the output should be, don't activate sprinklers. If it's not raining and the timer is on, the output should be activate sprinklers. Once you have your truth table, you can derive Boolean expressions. These are mathematical expressions that represent the logic of the circuit. Don't worry, it's not as complicated as it sounds. Finally, you would use logic gates to implement the circuit based on your Boolean expressions. The last step is testing. You need to make sure your circuit works as expected for all possible input combinations. This involves applying different inputs and verifying that the output matches your truth table. Designing combinational logic circuits is a fascinating process that combines logic, mathematics, and electronics. There are some common combinational logic devices that engineers use all the time. These devices are like pre-built modules that perform specific functions. One example is a multiplexer, or MUX for short. Think of a MUX like a railway switchyard. It selects one of several input signals and routes it to a single output. On the other hand, we have demultiplexers, or DMUX. These are the opposite of multiplexers. They take a single input and route it to one of several outputs. Imagine a DMUX as a mail sorter, directing letters to different destination bins. Another important pair is encoders and decoders. Encoders convert information from one format to another. Think of a keyboard. It encodes the keys you press into binary code that a computer can understand. Decoders do the reverse. They convert the binary code back into a readable format. Imagine a decoder as a translator, converting a secret code back into English. Now let's talk about arithmetic. Adders and subtractors are essential combinational logic circuits that, you guessed it, perform addition and subtraction. The most basic adder is the half adder. It adds two single-bit binary numbers. A full adder, on the other hand, can add 3 bits, 2 input bits and a carry bit from a previous addition. These adders are the foundation for more complex arithmetic circuits. By connecting multiple full adders, we can create circuits that add larger binary numbers. Subtractors are built using adders and a clever trick called 2's complement. This method represents negative numbers in a way that allows us to use adders for subtraction. Mastering these fundamental concepts of combinational logic circuits opens the door to understanding the inner workings of the digital world. From simple gates to complex adders, these circuits are the backbone of modern electronics. So, the next time you use your smartphone or computer, remember the amazing world of combinational logic circuits working behind the scenes.